Hi. Let's take a look at this limit. Well, as x approaches to 0, this is approaching to 1. This approaches to 1. 1 minus 1 is 0. This one approaches to 1. This one approaches to 1 as well. Then 1 minus 1 is 0. So the L'Hopital's rule, condition satisfied. You may try the L'Hopital's rule, right? And I don't want to spend time here because you will find that when you take the derivative, both numerator and denominator, and it becomes more and more complicated, and you may find out using L'Hopital's rule, but I come back to consider using some other methods. Okay, now what method? Here I'm consider for this one I'm using the binomial, right? Binomial. Well, binomial says that this is 1 plus x squared is 1 plus x squared to the half power, right? So after expansion, this one is first term, this is second term, and then third term, and half minus 1, right? X to the fourth. Then from this term onward, I know that the x, has more and more high power, and I don't have to expand them. I know that the remaining, the terms, they contains at least 5 x fifth is a common factor multiplied by a polynomial. Okay, that is expansion for square root 1 plus x squared. And for cosine x is equal to 1 plus, right? That is rather familiar, plus x fourth, right? 4 factorial. And then the remaining the terms, they are very high power for x power, At least they have x fifth, right? Times a polynomial. Okay, polynomial. That means every term has a containing at least x fifth power. And so the last one is e to the negative x squared. That Maclaurin series is 1. The first term is 1, right? The second term is this, negative x squared over 2. And then plus 2 factorial. And then this one has a negative x squared over 2 square, right? And 2 factorial. Yeah. And the plus. I know that after this term, x has very high power. At least I have a fifth. And then multiply by a polynomial of x. Okay? Then I substitute everything into the original limited question. We have the limit x approaches to 0, 1 plus half x squared minus this, right? Minus 1 minus half x squared, and minus, simplify this one. This is 1/4 negative. This is half, right? Then 1/8. So 1/8 1/8 x fourth. Yeah. Correct? Yes. Negative here, so it become plus. Okay, then plus x fifth times a polynomial. Okay, that's the numerator. And denominator is this, right? 1 plus 1 minus x squared over 2 factorial, which is 2, plus x fourth to the 4 factorial. 4 factorial is 24. Okay, plus a polynomial with containing x fifth as a common factor. And the minus this, minus 1, right? And minus this 1 becomes plus x squared. And this is a plus, therefore minus. This is a fourth, this is 2, therefore eighth, right? X to the fourth. And plus the remaining, these two terms, x fifth times g plus h, right? Okay. So far, so good. Then we take the limit as x approaches to 0. And one cancel out. This one cancel with that one. So left over is 1/8 x to the fourth plus x5 times f of x. And this one cancel out, and this is cancel. So they have x fourth plus over 24 and plus minus 1/8 x fourth plus x5 times a polynomial, which is g over h, right? Now we know that the polynomial, the leading term is a more dominate the whole polynomial, right? So we just take a look at this one. This one goes to 0, this goes to 0, this goes to 0, everything's done. See, this is the limit. X goes to 0, this one becomes 1/8, right? Plus x to this one, and this one is 1/24 minus 1/8 plus x times g plus h. Yeah. Then x approaches to 0, we find the answer is that this goes to 0, this goes to 0, 1/8, 1/24 minus 1/8. Yeah. So we multiply by 24th. So this is 3, this is 1, this is minus 3. So the result is negative 3/2. So that is our limit. Okay. Now let me go over briefly. We may consider by using L'Hopital's rule, but after struggling with differentiations, the long expansion of the derivatives, I'll come back to consider using some other alternative. Here I'm using expansion, this one for the binomial, and this one Maclaurin, and we expand up to x fourth. So the remaining terms, they contain x fifth. And then we, after simplification, then we find a limit. Okay. Thank you for your watching.